A developer tried to build his own version of this feature. He typed one command, hit run, and walked away. When he came back, he had burned through 2 billion tokens. 2 billion. On Opus 4.8, that is a hole in your bank account you could see from space. He only survived because he was running it on cheap DeepSeek. So, what was he chasing? This. Claude Code can now spin up 1,000 AI agents from a single sentence you type. It is called dynamic workflows, and it is the most powerful thing Anthropic has shipped all year. It is also the easiest way to set your entire token budget on fire. So, in the next few minutes, I will show you what it actually is. The one question that tells you when to use it and how to run it without becoming that developer. Before any of the hype makes sense, you need one question burned into your head, and it runs through this entire video. Where does the plan live? Think about it. When an AI agent does something complex, somewhere there is a plan, a list of steps, a decision about what to do next. And the single biggest thing that separates dynamic workflows from everything that came before it is not the speed, and it is not the number of agents. It is where that plan is stored. Hold on to that question, because the moment you see the answer, this entire feature snaps into focus. So let us climb the ladder. Level 1, a single agent. It reads files, it calls tools, it makes a plan, and all of it lives inside one context window. Simple, but it can only hold so much. Level 2, subagents. Now a lead agent splits the work and hands pieces to helpers, each with its own context window. But here is the catch. The plan still lives in the lead agent's head, and the subagents cannot talk to each other. So two of them can quietly do the exact same job twice. Level 3, agent teams. Now they share a task list and can coordinate. Better. But that plan is still just text sitting inside a context window. And then there is dynamic workflows, where the plan stops being a thought inside a model's head and becomes something completely different, real code. Here is the part that actually matters. When you trigger a dynamic workflow, Claude writes a JavaScript program, an actual script. Inside it, an orchestrator breaks your task into subtasks. Each subtask gets handed to an agent. Then independent verifiers review that work and try to poke holes in it. A fixer cleans up what they find, and a final agent assembles the report. A runtime executes that whole script in the background while your session stays free. And the results do not pile up inside Claude's context window. They live inside the script's variables. That right there is the answer to our question. The plan is now code you can open, read, version, and run again tomorrow. It is built from a few simple pieces with names like agent, parallel, and pipeline. Claude writes them for you, but you can read every single line. Now, why go to all this trouble? Because of one loop. Implement, verify, fix. And it is not gentle verification, it is adversarial. A separate agent with its own fresh context is told to attack the work and find what is broken. Then an independent fixer repairs it. Implement, attack, repair until it finally holds. That is why the output is often dramatically better than a single agent grinding away alone. But, and this is the whole ball game, that loop only works if there is something real to verify against. A test suite, a build that either passes or fails, an objective bar the agents can measure themselves against, no bar, no loop, no magic. Quick reality check, because the headlines oversold this one. The blog post says hundreds or thousands of agents, and technically that is true. But there is a ceiling. You can run 16 agents at the same time, with a hard cap of 1000 total in a single run. So it is massively parallel, yes, but it is not infinite. 16 at once, 1000 per run. Keep that number in your head because it quietly shapes everything about when this is actually worth it. Which brings us right back to our developer and his 2 billion tokens. Here is why that happens. Every one of those agents, every verifier, every fix loop, every retry burns tokens, and they all run in parallel. So the meter does not tick, it spins. People are lighting thousands of dollars on fire with this feature and getting nothing back because they aimed all that horsepower at the wrong kind of problem. Our developer actually got off easy. He was on DeepSeek, which is cheap. Run that same 2 billion token job on Opus 4.8 and you do not get a warning. You get a bill. Power this big always comes with a price tag, and the entire skill is knowing when it is worth paying. So, when does it backfire? Anytime there is no objective way to measure success. Ask a workflow to write 10 versions of your website's copy, and the agents have no idea what good even looks like. There is no test for taste. It is just very expensive vibes. Same story if you ask it to rewrite your own custom skills or anything creative and subjective. You will spend a fortune and get mush. And even when it works, stay honest about what you are getting. Anthropic's flagship demo was Bun, migrating 960,000 lines of code from Zig to Rust in 11 days, with 99.8% of tests passing. Genuinely incredible. But the migrated code carried over 13,000 unsafe blocks, compared to just 73 in a version written by hand. It ran, it passed, but it was not automatically production ready. The machine is fast. It is not magic. So, where does this thing genuinely shine? Picture the exact opposite of vibes. A code base wide bug hunt where every fix either passes the tests or it does not. A security sweep across hundreds of files hunting for missing auth checks. A giant migration, like that bun port, where the test suite is the judge. Or deep research, where a dozen agents each chase a different source and then cross check each other to throw out whatever does not hold up. Notice the pattern. Every single one has a clear, automatic definition of right and wrong. That is the soil this feature grows in. Give it an objective bar, and 1,000 agents become an army. Give it a vibe, and they become a very expensive committee. Let me hand you the exact decision tree so you never have to guess again. Question 1. Is there an objective way to measure success? A test, a build, a fact you can check? If the answer is no, stop right here. Do not use a workflow. If yes, question 2. Do you actually need to fan out across hundreds of files or sources at once? If no, a single agent or a little sub-agent orchestration will do the job for a fraction of the cost. If it is yes to both, then and only then you reach for dynamic workflows. 3 questions. That is the entire filter. Most tasks fail question 1, and that is exactly the point. Now watch what it looks like when you do it right. The creator whose video inspired this ran a real one. He had a local meeting app and wanted to migrate its models of Apple's MLX framework and over to transformers. A perfect candidate because he could test the new version against the old one. Objective bar logged in. He typed the request, and the workflow did not ask him how many agents to use. It decided on its own. 4 phases, about 12 agents. Before spending a cent, it stopped. Warned him this would use a lot of tokens and asked permission to continue. He said yes. It built, it ran the tests, it passed. Total cost around 750,000 tokens. Now compare that to 2 billion. Same exact feature. The only difference was a real test to aim at and a human in the loop saying go. So here are the 3 laws to carry with you. 1. It is code, not context. The plan lives in a script you can read and rerun. And that one shift is the whole breakthrough. 2. It only earns its cost when there is an objective, measurable outcome. No test, no workflow. 3. Run it wisely because the power is real and so is the bill. To switch it on, just drop the word workflows into your prompt or set your effort to ultra code and let Claude decide for you. That is it. I packed the full decision tree, the good and bad use cases, and a token safety checklist into one free guide. So you never burn 2 billion tokens by accident. Comment the word swarm and I will send it straight to you. If you want the deep dives, they live here on YouTube. So subscribe. And the bite sized drops are on Instagram at Hyperautomation Labs. Now go build something an army of agents can actually measure.